So this question gives us the speed of a wave on a string, which is 440 meters a second, and its frequency that someone is trying to produce on that string, 220 hertz. And the question is, if one end of the string's closed and the other is open and free, and we're in second harmonics, what must the length of the string be for it to produce that? Okay, so the first thing you would do is given frequency and speed, you use the formula V is equal to lambda f, and we try to find for lambda. So lambda is equal to V over f, which is equal to 440 meters a second over frequency, my bad, 220 hertz. Okay, and then we need a calculator to solve this one. No need of a calculator. This is just simply going to be 2 and meters, because hertz is in like seconds. So 2 meters. So basically, if I had a wave like this, that means the distance from here to here is 2 meters. So now we have to go into harmonics and see, well, how much of this wavelength must be produced to have a second harmonic on a string with one end free. Okay, so to draw the harmonics of one end free wave, basically start with the shortest wavelength. If we had a tube like this, and this end is fixed, so there's going to be a rope there, then the first harmonic would simply be going to the max. It's going to basically oscillate up and down in here. This part is going to move up and down, and this part is fixed. This would be the first harmonic. And in this case, this would be a quarter of a wavelength. This is a quarter of a wavelength. This is the first harmonic. This is the first. The second harmonic then would be, if I draw a longer tube, this end is fixed. Well, I'm going to go up. That's my first harmonic. So to continue on, I'm going to come down. But then I'm in the middle. Like, this is those would have been a fixed end. So nudge it there, and I'll go like this. And then now I'll see, yes, this is opened. So I reach the maximum. In other words, if I would do the up when the string moves the other side, it will go something like this. And you can see that if I were to continue up to here, this would be a full sine wave, a full wavelength. So if this was a quarter of a wavelength, then this would be a half, and then this would be 3/4. And this is the second. So if this is the second this is the second harmonics, then this is 3/4 of a wavelength. And we know our wavelength is 2 meters. So when I plug that in, I get the answer to be L over here. L is equal to 3 times 2 meter over 4, which is equal to, the 2's will cancel, 3 over 2 meters, or 1.5. And that's our answer, that's our length.